the highly anticipated 3-minute thesis competition. And before we get started, I'll tell you a little bit about the competition. You're in for a treat today. So we'll talk a little bit about it, but first I want to give thanks to the folks who are helping us sponsor our 3-minute thesis competition. They're putting out some money so that our folks who are competing can actually win something. We're being sponsored by our GPSG, which is our Graduate and Professional Student Government, our Underrepresented Professional and Graduate Student Organization. There's some funds coming from the 50-year funds, and we're grateful to those folks. Also like to thank our IUPUI Graduate Office and, of course, the Preparing Future Faculty and Professionals program. So with that, I'll tell you a little bit about the 3-minute thesis competition. It started at the University of Queensland, so all of this stuff is branded for the University of Queensland and branded for the 3-minute thesis competition. And this is where PhD students have 3 minutes to present their research, okay? And so what the 3-minute thesis really is supposed to help with is facilitating that communication. And so we heard from our panel earlier that sometimes we as researchers don't effectively communicate with people. And yeah, that happens, right? So, so this is to help, okay? And this happens nationally and internationally. This is our campus competition. Other campuses around the state will also have competitions, and then the winners from those campuses will move on to our regional competition. So this happens all over the world, not only here in the U.S., but in UK, New Zealand, lots of places. So today we have our esteemed judging panel. Wave judging panel. Okay. Dr. Shanique Edwards is a postdoc fellow at the School of Medicine. Dr. Wayne Hilson is the Senior Director for Diversity, Equity, Inclusion, and the Director of the Multicultural Academic Relations here at IUPUI. He's also one of our PFFP Advisory Board members. And Dr. Carmen Williams is a postdoc fellow in Public and Population Health Informatics at Regent Street in the School of Public Health. So the rules for this 3-minute thesis, and the folks who are competing are well aware of these, is that you have to have one slide. That's it. One slide, 3 minutes. The slide is static, which means there's nothing that's going to be flying in or floating around, no animations, no movement, and no additional electronic media, so nothing's going to start singing at you. No additional props, no costumes. So really just you and your research. Oh, yes, right. 3 minutes. We have a timer, so raise your hand. Someone's going to give people cues for 1 minute, 30 seconds, and then they have 10 seconds left. And if they go over 3 minutes, then yes, we will be penalized. So we will speak, no poems, no raps, no songs. And we will commence from this area, and if you guys want to use the mic, you can. If you don't, it's perfectly fine. We also have a hand mic we can try and hit you up with, a movable mic, okay? Let's see, and then whatever our judges say goes, okay? So, but we also want you guys to get involved too. So on our campus, the winner of our 3MT is going to win $500 and a travel award to compete at our Midwestern Association of Graduate Schools annual conference. That happens in the spring. With our 3-minute pitch, that person is going to win $350. So the difference here, 3-minute thesis, 3-minute pitch, we won't make really any differences today. But the 3-minute thesis person is a PhD, and then a 3-minute pitch people are involved in professional programs or master's programs. And then you guys in the audience also get involved, where we'll ask you at the end to vote on your cell phones or electronic devices for your favorite. Who is your favorite presentation? And they will win $150. So pretty awesome for 3 minutes of work. So we're going to go in the order that is on the back of your agenda. And we're going to start with Brady Kepler. He's a student in English in the School of Liberal Arts, and he's going to talk to us today about the language teacher's imperative, understanding learner responsiveness to innovation.
799 million individuals worldwide have not learned to read or write. Significantly, a large portion of these individuals have learned to speak a second or additional language. At IUPUI alone, nearly 2/3 of students enrolled in basic ESL classes identify as coming from low literacy backgrounds, meaning they have not yet gained essential literacy skills in their first language. And now they're expected to learn and engage in literacy skills in their second language. This is significant, especially since what we know about second languages and how additional languages are learned is based on research that is done with individuals who have already gained literacy skills in their first language and are now learning a foreign language. So my research is focusing on students who identify as coming from low literacy backgrounds. And I'm investigating how they're responding to literacy instruction in second language, which is English. So what I'm seeing is that the most effective instruction is that which uses much metalinguistic terminology. Metalinguistic terminology essentially is language and terms we use to talk about language. But it's not just giving students a list of metalinguistic terminologies or complex definitions, because that keeps learners confined to one specific context. Rather, applying metalinguistic terminology to a visual image, like a picture, so learners can create a mental image, is the most effective that I'm seeing. So take, for example, the term semantic cohesion, which is a term that essentially means that ideas are tied together because they represent similar thematic ideas. So if I were to write a paragraph in which the topic sentence is about fruit, and the following sentence is about apples, I've created semantic cohesion. So what I'm doing, though, is taking, say, an image of a bird's nest with an egg in it. That image represents semantic cohesion. So that fruit is the nest, and apple is the egg. So learners are able to transfer concepts like semantic cohesion to a number of academic disciplines. They can apply semantic cohesion to, say, a grant proposal or a cover letter, and it's helping them be more successful in all academic disciplines at IUPUI. Thank you.
Next, we'll have Arias Matos, who's a student in the School of Dentistry. He'll talk about chlorhexidine gel film minimizes bacterial colonization and preserves biocompatibility of titanium-based material.
Hello. Whenever the implant is inserted in the oral cavity, it is colonized with bacteria present in the mouth. In some cases, it can cause an inflammatory process in the soft tissues around the implant. This condition shown on the right-hand side of the slide is called periodontitis, and it may cause failure of the rehabilitation treatment. The surface of prosthetic components which connect the prosthesis to the implants have an important role in microbial and teachable tissue adhesion to the surface of the material. Researchers have tried to modify the surface of the implants and prosthetic components to produce multifunctional surface that provides adhesion to provide the reduction of the biofilm on this material. Nevertheless, this failure such multifunctional surface, as can be called as smart surface, and these studies show either bacterial reduction or improvement in mammalian cell viabilities. However, they do not show growth results at the same time, until now. To overcome this problem, the purpose of my research was to develop a new smart surface for implants and prosthetic components with both antimicrobial and biocompatibility properties. How is that possible? As part of my thesis, our research team used a surface treatment that depositioned a thin film on the implant surface, and this film had excellent properties for adhesion of all cell types, but also promotes bacterial attachment. To bypass bacterial attachment, we introduced chlorhexidine in this film, which is an antimicrobial agent capable of eliminating different species of bacteria. In conclusion, we have developed a new multifunctional surface treatment for implants that releases this antimicrobial agent reduced to bacterial adhesion without causing toxicity to gingival cells. In other words, my research will help to prevent the inflammation process in the soft tissues around the implants. Now, let's take a look at this picture again. With the use of this treated implants, my goal is to improve the success rate of the implant therapy. What you see on the right side, promoting rehabilitation and oral health, as you see on the left side. Thank you.
Now we'll have Shaquita Dent, who is a student in kinesiology and exercise science, and she'll talk to us about the effect of music on virtual reality-induced postural sway.
Well, Granny, using virtual reality creates movement of a visual environment, and it's been used for people who have balance deficits. Kind of like how Dad always has trouble standing in place and maintaining his balance when he's using his prosthesis. Well, my research combines the use of music with virtual reality with hopes that music will increase postural sway. So far, I've seen that when music is played at a much slower rate than the virtual reality scene, it increases postural sway more so in the backwards and forward direction rather than the side-to-side sway. My study is unique in the sense that there's not much data combining the use of music and VR. So maybe one day, clinicians can use this approach as an alternative form for balance training programs. Does that make sense? Thank you.
So next we'll have Soumya Tapas, who's a student of bioinformatics, and she will talk to us about Dr. Machine, healthcare through machine learning.
So we all face certain kind of issues in our day-to-day life, including they are not very complicated, but there are things like how do I lose my weight or how do I get rid of a pimple. These are, unless and until it's not severe enough, we do not visit a doctor. But most of us, we search it and then how to get rid of pimples. So let's stick to the pimple example for now. And then the problem is we have so many resources, so many suggestions. So when we go to a doctor, the doctor would see certain aspects like your skin type or hormonal changes, and then they prescribe certain things. So my idea is, why not allow the computer to learn and do those things for us? Basically learn your skin type, learn the way, what are the hormones that's going on, or the irregularities of your day-to-day life, and then suggest certain things, and also at the same time suggest, in case it is more severe, tell you that you need to go to a doctor and visit the doctor now. So the second thing is, why do you need this, right? The first thing is the first aid, right? We need certain kind of first aid, because as I said, we don't visit the doctor as soon as we face certain issues. The second thing is, the doctors aren't available every single time. You need to get rid of certain things as soon as possible, and these resources are there and you can do it in the house. And why? One more thing is, it's kind of easy. There are certain home remedies and there are certain medicines which you do get without this prescription. And how do I do that? It doesn't seem easy to learn so much and tell you these things, but we can do it. As you see that the machine is learning and it has kind of graduated there. So the machine, the data, what you have, we make a machine to recognize and learn the data, the information that is already there in the real world, and then predict based on that. So basically, if there are 10 people who have a similar skin type, it will judge these people, this medicine or this home remedy or a medicine as a drug itself has worked on this many people, then with this person who has a similar kind of a skin type and other kinds of your hormones and everything, this can eventually help you. So it's going to predict. So this is going to work at a easier level. It's going to be more clear, and at the same time, it's an easy access. You need not panic over so many things that is there, so much of data that is there in the world. You can restrict your thoughts and your actions basically with one tool. That's all. Thank you.
Steffi. And Steffi's going to kind of talk to us about human-computer interactions and instant fame and the role of Instagram.
Visit to museums can generate a lot of mixed reactions. Sometimes it can be very intimidating, sometimes very surprising. Personally, I've experienced it, and sometimes it can be boring too. So, one of the visits to this museum with my professor make me realize that people generally interact with the museum exhibits for less than 2 minutes. And if they are not able to fully operate with the installations, they often leave thinking that it's not working. And also, people, they do not interact with the museum installation much in a interesting way. So here, we are trying to solve the issue. We just came back from the museum and we realized, how could we solve this problem? How do we make the museum exhibit more interesting and engaging to the people? So we looked into this problem and researched on how other museums work towards this issue. And we realized that all the museums, they work in a similar way. People come, they look at the museum exhibit, they move on without much interaction. So this is a big problem, and we do not want to have the same experience in this museum. So here, our solution, like my team and I, we came up with the solution of full body interaction, where the person can interact with the data in the map, having hand gestures and the body movements. So like you can see here in the presentation. So wouldn't it be interesting for you to have the interaction with the data in the map with the help of a full body interaction? Don't you think it would be more fun having an interaction that involves your body instead of controlling it via any remote control? No hardware, more of a natural user experience gives more control to the user. It allows more experience as well as the better human experience, which will give a wholly immersive experience to a user. Basically, my challenge here is to identify a list of data sets that could be utilized in the form of interesting way and interpreted in various ways. One of the factors could be understanding the causation and the correlation factor that could be displayed in the map. A simple example could be ice cream sales and the number of drownings. So both are strongly correlated, but one do not cause the other. So this is how it leading people to understand that the causality is there, but there is none. But also the relation that the correlation will be occur, which is mostly does not happen. So, but the data exploration with the help of this map will be a really difficult part. So that's how we are trying to explore the 4 strategies that could be implementing. First, it will be implementing the flow. Second, forcing collaboration. And third, how the person will be able to visualize the silhouette as you can see in the presentation in the form of the data. And the fourth one will be how the data could be implemented in a very easier way. So we are trying to work on this project, and if implemented, we'll be really happy to test it with our users, and also this will help us to have you interact with the museum exhibit in a really engaging way. Thank you.
And our last competitors is Sharvesh, and Sharvesh is going to come to us from the School of Medicine and talk about the persistence of HIV viral protein F and the perplexingly high prevalence of vascular disease in HIV patients.
The 1980s was a strange time. For example, spandex was everywhere. And in 1981, the Center for Disease Control reported that young men in San Francisco were dying of strange infections. This was a disease that was given the name AIDS and attributed to the HIV virus. Since then, modern medicine has worked this miracle, and today's HIV patients can be effectively treated to block viral replication, and the virus is now banished out of the bloodstream and into a few cells scattered across your body. So these patients are not dying of AIDS at the same rate they were in the 90s. But yet, they remain at a much higher risk for developing diseases of your blood vessels. For example, if you look at the peripheral arterial disease in your legs, emphysema in your lungs, or heart failure, HIV patients have a much higher risk of being diseased. So when posed to the question, when there's no virus in the blood, what is damaging these blood vessels? I propose that while the virus is in exile and cannot replicate itself, it still continues to manufacture one protein, NEF, and packages it into vesicles and secretes it into our bloodstream, where it's left unchecked to wreak havoc on our entire vascular system. When I looked in the blood and lung of nearly 70 HIV patients, I found that this protein persists in nearly half of them. And this is bad news, because endothelial cells that line the inside of our blood vessels and play an important role in the normal function of our blood vessel readily absorb NEF, after which they die. This impacts the ability of our blood vessels to function properly, leading to diseases like hypertension and heart failure. So during my thesis, I explicitly characterized the mechanism through which NEF is capable of causing this damage and come up with two possible solutions. The first is using EMAP2, a protein that NEF uses to magnify and amplify its own ability to kill cells. And so when I used a neutralizing antibody that blocks EMAP2, I was able to rescue these cells. The second strategy is like teaching an old dog new tricks. Statins is a class of drug that has been prescribed to billions worldwide because it blocks cholesterol production. But one of the added bonuses is that it also blocks pathways that NEF uses to kill cells. So a combination of using EMAP2 neutralizing antibodies, which are in preclinical trials, and repurposing an FDA-approved statin drug can be used to keep HIV patients healthy. Tomorrow is World AIDS Day. Just like how we have moved on from wearing spandex in the 80s to yoga pants now, it is time for us to update our approach to not just stopping AIDS progression, but also trying to keep HIV patients healthy by fighting NEF.
Awesome. So now it's your time to get involved. We're going to use Poll Everywhere, and I'll show you guys the next slide, and it will have a letter beside each of our presenters.